In this video, we're going to look at proving trigonometric identities. So let's take the first example. So we have 2 sine theta over 2 cos theta over 2 cos theta. Now we're trying to show that we get half sine 2 theta. So what I'm going to do is just focus on this part and rewrite that here. So 2 sine theta over 2 cos theta over 2. Well, there's a well-known trig identity that says that 2 sine theta cos theta is exactly the same as sine 2 theta. So whatever is this theta, this is double of it. So notice I've got theta over 2, theta over 2. So if I do 2 times theta over 2, that's simply going to give me theta. So in other words, I could rewrite this as sine 2 times theta over 2, because that will be exactly the same as 2 sine theta over 2 cos theta over 2. So in other words, we're saying that sine theta is exactly the same as 2 sine theta over 2 cos theta over 2. So if I go back to my question now, I could write that as 2 sine theta over 2 cos theta over 2 times cos theta. But we've just shown that that first part is the same as sine theta. So I can say I get sine theta times cos theta. But we just said that, well, if you have sine 2 theta, that's exactly the same as 2 sine theta cos theta. Now to get sine theta cos theta on its own, that's going to be half of sine 2 theta. So we can say that this is the same as half sine 2 theta, which is exactly the same as the right hand side, and we have proved our identity. Now if we take part B, we can say, well, we have 1 plus cos 4 theta. But we can start off with an identity that we know, that cos 2 theta. Now, because we got a cos squared in our identity, we should know that one of the double angle formulae for cos 2 theta is 2 cos squared theta minus 1. So now that I have that, I can now say, well, I want cos 4 theta. So remember that this theta is half this 2 theta here. So this must follow the same pattern. So it's going to be 2 cos squared. We half 4 theta, which is 2 theta minus 1. So now what I can do is to replace cos 4 theta with what we have, which is 2 cos squared 2 theta minus 1, and I end up with 2 cos squared 2 theta, which is the same as the right hand side, and I have proved my identity. Here's the next example. So we need to show that tan 2 theta is 2 over cot theta minus tan theta. So what we're going to do here is we're going to write out what tan 2 theta is. Well, tan 2 theta is exactly the same as 2 tan theta over 1 minus tan squared theta. So because I want to get a 2 on the top, if I divide the top by tan theta, I'll get a 2. But I need to be consistent. I need to divide everything by tan theta. So I'm going to write that out again here. But I'm going to leave a little bit of space so you can see that I'm dividing everything by tan theta. So we need to divide this by tan theta. So the original's in pink, by the way. And then on the denominator, so now we're going to divide everything by tan theta again. So divide by tan theta here, divide by tan theta here. And what we end up with is a 2. Then we get 1 over tan theta minus tan theta. Now we know that 1 over tan theta is cot theta. So we end up with 2 over cot theta minus tan theta, which is exactly the same as the right hand side, and we've proved our identity. Here's the next example. Well, this example we have to be a little bit careful. So if we start from the left hand side, it's not intuitive to make the right hand side, but I know that the right hand side is based on a trig identity that I'm familiar with. So if I write out the identity for cos A minus B, which for A level you should certainly be familiar with, and I have written this out several times in previous videos, is cos A cos B plus sin A sin B. So what that means is that we could write the following as 2 cos 4 theta cos pi over 6 plus 2 sine 4 theta sine pi over 6. Now, so what we have is we could write this as 2 cos 4 theta. Now, cos pi over 6 is the same as cos 30, which is root 3 over 2, plus 2 sine 4 theta, and sine pi over 6 is the same as sine 30, which is half. Now the 2's cancel out here, so I'm going to cancel them out, and we end up with root 3 cos 4 theta plus sine 4 theta. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. Okay, from this question, we're going to start from the right hand side. And we're going to expand the brackets, so it's 2 cos 2 theta cos pi over 3, and then we're going to have a minus 2 sine 2 theta sine pi over 3. So we can say that's 2 cos 2 theta, or cos 60 is a half, minus 2 sine 2 theta and sine 60, which is pi over 3, is root 3 over 2. Just as in the previous video, we can cancel these out. So we end up with cos 2 theta minus root 3 sine 2 theta, which is the left hand side. I do realize that in the previous example I should have written left hand side as opposed to the right hand side. So that was proved. Here's an example for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. Now I like this particular example because it's a well-known example that comes up when you come across integration. So if you can get used to this, then you would find your integration techniques quite smooth. So what we're going to do is we're going to say, well, I know a trig identity that says that cos 2 theta is identical to 2 cos squared theta minus 1. So if I notice, instead of a cos squared, I've got a cos to the power 4. So what I'm going to do is rearrange this. So we've got cos squared theta as the subject. And we've done this in the half angle formula. So in previous videos. So this is going to be 1 plus cos 2 theta all divided by 2, like so. But then if I want to do cos to the power 4 theta, I'm going to square all of this. So if I was to square all of that, it would mean I would get 1 plus cos 2 theta squared. When I square the bottom, or the denominator, 2 squared is 4. Now I can use this well-known identity in algebra, that a plus b all squared is a squared plus 2ab plus b squared. So I can do the same thing here. So I can say 1 plus 2 cos 2 theta plus cos squared 2 theta all divided by 4. So notice everything's in terms of cos 2 theta and cos 4 theta. Well, what we can say is I can manipulate this cos squared 2 theta because I know what cos squared theta is. So that means I can say that cos squared 2 theta means I need to double this angle, would give me 1 plus cos, as in we're doubling this angle, cos 4 theta over 2. So I can now substitute that in. So I can do 1 plus 2 cos 2 theta plus, and I'm going to write that in pink so you can see what I'm doing. It's going to be 1 plus cos 4 theta. Now be careful here. It's all divided by 2. And then don't forget, now we're going to divide everything by 4. Like so. Now what I'm going to do is separate the fractions. So I'm going to get 1 over 4 plus 2 cos 2 theta over 4, like so. And then do 1 plus cos 4 theta over 2. And I'm going to put all of this like this and say divided by 4 for a reason. Now I get 1 over 4 plus a half cos 2 theta. Then I get plus 1 plus cos 4 theta over 2. Don't forget this is over 1, so that's times 1 over 4. So we can put this in brackets if you like. So now we end up with the following: 1 over 4 plus a half cos 2 theta. Now it's very important that you put brackets around that because it's more than one term and the quarter gets multiplied by both terms. So we get plus, we could write this as a quarter times a half plus a quarter times a half of cos 4 theta. So what I could do as well, if you're not sure about that step, I'm going to factorize the half out first, then you can be able to see it more clearly. So I'm going to do a quarter plus a half cos 2 theta. I'm going to factorize the half out because there's really a 1 here, and then I'm going to put times a quarter here, and then I'm going to do plus 1 plus cos 4 theta, like so. So we're taking the half out, taking a quarter here, and in brackets we get 1 plus cos 4 theta. So now what we end up with is a quarter plus a half cos 2 theta plus 1 over 8 times 1 plus cos 4 theta. Now what happens is we get the following: a quarter plus a half cos 2 theta plus 1 over 8, through the clarity of that, plus 1 over 8 cos 4 theta. So we can only add fractions if you have the same denominator. So now we get 2 over 8 plus 1 over 8 plus a half cos 2 theta plus 1 over 8 cos 4 theta. And now we're going to get exactly what they're looking for, which is equals to 3 over 8 plus a half cos 2 theta plus 1 over 8 cos 4 theta.